You see clouds. Sometimes you see the sun poking through, and if you look beyond the clouds, you see the stars, and if you look beyond the stars, galaxies. And if we put the most powerful telescopes on the most distant objects, what we see are seemingly an endless array of galaxies that seem to go and go and go. But is there a point where we can see even beyond the galaxies? And in fact, there actually is. Back in 2004, a satellite was sent up to take a picture of the origin of the universe. And if you look out beyond the clouds, beyond the stars, and beyond the galaxies, what you see is an energy that seems to have a uniformity in its non-uniformity. It's anisotropic. You see, it's kind of like the dew that you see across the top of this surface. There's a uniformity in its non-uniformity. There doesn't seem to be any one spot that is more or less concentrated with the dew drops. But there must be something that's causing the drops to form more here than here. That's anisotropy. And without an anisotropy in the universe, we wouldn't have had stars form or galaxies condense. What the astronomers believe should be the case is this. Since we've got galaxies everywhere in the universe, that meant that the universe couldn't have formed with an even distribution of energy. There had to be a certain amount of unevenness to it. There had to be regions of the universe where some areas were hotter and some areas were cooler. The cooler areas would have been where the galaxies would have condensed. If that weren't the case, then what we observe would make no sense. So when the universe was observed closely in 2004 with the Wilkinson microwave anisotropy probe, what it saw was exactly what they expected to see, which was an uneven distribution of energy. If this weren't the case, what they would have seen would have been a wash of stars everywhere or no stars at all.